In case of capacitor, what we can say? Charge storing capacity is maximum at minimum potential. So Q is directly proportional to V, where Q is equal to nothing but C. C is to be called as a capacitance. Means you have a formula. C is equal to Q upon V. This is a formula for capacitance. Now charge unit is coulomb, potential unit is volt. If I am saying that I am going to deposit 1 coulomb charge so that the developed electric potential is V. So the corresponding capacitance is to be called as a 1 farad. So farad is one of the unit of capacitance. How you can define that? The capacity of a conductor is said to be 1 farad if 1 coulomb of charge deposition rises the potential of that capacitance through a 1 volt. Then the capacity is said to be 1 farad. Now this farad is the highest unit of the capacity. It has a lowest unit like your millifarad. So 1 millifarad means 10 raised to minus 3 farad. 1 microfarad means it is equal to 10 raised to minus 6 farad. 1 nanofarad means it is 10 raised to minus 9 farad. And 1 picofarad, which is equal to 10 raised to minus 12 farad. Now this is about your capacitance. Now here from this formula we can give the dimensions also. Now while writing the dimension I can use the formula. Q charge, which can be written as I into T. Potential, which is nothing but work. So I can say that IT means I raised to 1, T raised to 1. Work means force into displacement. So dimensions of force can be written as, so here I can say that force into displacement dx. So I'll write down dimensions of charge I raised to 1, T raised to 1 divided by force dimensions. I can write down M raised to 1, L raised to 1, T raised to minus 2, and dimensions of X. Dimensions of X is nothing but L raised to 1. Now this L raised to 1 and L raised to 1 means it will become L raised to 2. Means final dimensions of capacitance will become M raised to minus 1, L raised to minus 2, I raised to 1, and this T raised to 3. This is nothing but your dimensions of capacitors. So this is about the general information about the capacitors. Now these capacitors are of 3 types. In that, the first type of that capacitor is nothing but the parallel plate capacitor. Now parallel plate capacitor means what? There are 2 plates of equal area, equal material. One plate is charged. So on one plate charge deposited is Q or the area A. Second plate is connected to the earth. So induced negative charges will get introduced from the inner side of the plate. So that lines of force will start from positive charge to induced negative charge. So this yellow color arrow indicates direction of electric intensity. And these 2 plates are separated by distance. Now what happens? Already in the electrostatic application we have seen electric intensity due to infinitely long sheet. Now this is one conductor of infinitely long length. This is second conductor of infinitely long length. On first plate charge is Q. On second plate charge is minus Q. So first plate also gives rise to intensity. Second plate also will give rise to intensity. First plate intensity direction is outward. Second plate intensity is inward. So at the outer region, electric intensity E can be written as your formula sigma upon twice epsilon 0 minus sigma upon twice epsilon 0 is equal to 0. First electric intensity is due to plus charge. Negative electric intensity is due to second charge, which is equal to 0. Because their directions are outward. While inside the plate area, this electric intensity E, in the inner region, I can say in more clear language, in the inner region, I can say that intensity is sigma twice epsilon 0 plus sigma upon twice epsilon 0. Now, might be the question comes in your mind, why here is the plus sign? From plus Q charge, intensity is here. From negative charge, intensity is outward. So their directions of intensities are parallel. As they are parallel means their intensities will get added. And now your intensity will become twice sigma upon twice epsilon 0. 2 factor will get cancelled. So intensity in the inner region will be sigma upon epsilon naught. Sigma is nothing but your surface charge density of the plate. Area of the plate is A, charge is Q, means I can say that sigma is equal to Q upon A. If your sigma is equal to Q upon A, your intensity equation will become Q upon A epsilon 0. That is nothing but the intensity equation. And now from that intensity equation, now I can write down for potential. Your potential V is equal to E into D. Now how it is? Potential is your work. Work is equal to your force into displacement. So your intensity, your electric potential V is equal to E into D. Your value of E is equal to Q upon A epsilon naught into D. This is your V. And now from this V, now I can write for capacity. Your capacity formula is C is equal to Q upon V. So I can say Q divided by V. V is this formula, Q upon A epsilon 0 into D. Your Q factor will get cancelled. And therefore, now I can say that your capacity formula will become, capacity C can be written as A epsilon naught upon D. At the same time, same formula I can write down, C is equal to A epsilon naught or only epsilon upon D. Here capacity is directly proportional to area and inversely proportional to the spacing. So if the spacing between the plate will goes on increasing, capacity will goes on decreasing. If area increases, capacity will goes on increasing. So this is nothing but your formula for capacity of parallel plate condenser. Thank you.